All right, this is a quick video to show how to set up the Triggerscope 4 in MicroManager Gamma 2 using MicroManager firmware. You probably already have MicroManager 2 Gamma, but if not, you want to pull that down from the MicroManager Nightly Build website. That's the best place to get it. And you want to get the 64-bit version. If you have MicroManager 1.4, strongly suggest updating. I don't know if 1.4 is even working on newer systems as of, this is Q1 of 22. So we're going to focus on MM2 Gamma, and I'm using the newest version of the Triggerscope. This is Triggerscope 4, and I'm also using the newest Triggerscope firmware, which if you purchase a Triggerscope and in the comments on your online purchase, or if you send in a PO, just make sure to say what firmware you want. You can either have the ARC firmware, which will run a little bit more verbose and do some things regarding sequencing a little differently, or really if you're running MicroManager, then the right firmware to run is Nico's MM firmware for the Triggerscope. So let's go ahead and get started with this. The first thing I'm going to do is confirm the serial port that I'm using for my Triggerscope, and I'm going to do that by going to the Windows icon. I'll right click on that and I'll select the device manager. So what I'm going to look at here is the COM port where this is connected, and I just only have one device. If you have multiple devices, the simple way to figure this out is to unplug your device and then the COM port will disappear. I'll go ahead and do that right now, and you can see that the COM port disappears, and then I'll plug it back in, and I'm just unplugging and plugging in the USB cable. So now I'm convinced this is on COM7. All right. Next thing I'll do is load up MicroManager. I'm going to use a demo configuration. So this has like just vanilla, what you get off MicroManager if you download it fresh from the internet. All of these are demo devices. Snapping images produces a fake image, stuff like that. So that's cool. That's what I want. Next, I'll go to the devices menu and I'll select the hardware configuration wizard. Now, I'm going to assume we'll pull down a couple of DAC channels, and we'll assume that one of those DAC channels will be a Z motor control. So we'll go ahead and modify the demo file here. That'll keep everything kind of already set up over here. We will have this demo stage camera to deal with. That's okay. Next, I'm going to go down and I'm going to find the Triggerscope. It's going to be under the T, alphabetized T list here. And I'm going to choose Triggerscope MM. Again, this is the firmware developed by Nico Sturman, and his firmware is really tightly integrated with MicroManager. Works great. So I do recommend you use that if you're getting a fresh start here. If you have an old system, a legacy system, it's kind of you can choose either one depending on what firmware you have or what you're comfortable with. We're going to select the MM Triggerscope Hub. Now, at this point, all we need to tell it is the port for the Triggerscope Hub. And the way MicroManager is set up, the hub is like the core device, and then we attach items to that device after we've connected it. So here, our value is going to be the serial port, which is COM7. All right, a little bit farther down, you can choose almost any baud rate, but the primary baud rate that this unit was designed to interface at is 115.2. So I'm going to choose that. That's the communication speed. Everything else here you can leave as default. If you'd like, you can turn on fast USB. All right, so we'll talk to the Triggerscope. Now, the next step, this is an important one. What we're going to do here is we're presented with a whole bunch of options on the right, and then each one of these options is pulled from this adapter library. This is the core, kind of like the hub library. And if we go through this list, we have two TTL banks. So this is bank 0, bank 1. They're 8 values each. So I'm just going to turn on all of them. This gives me control over each of the TTL outputs. And then I have my DAC channels. So generally, if you're not going to use TTL 9 through 16, so like let's say you've got a 4-line laser launch and you have a 1 Z value output stage. What I want to do there is I want to choose, let's say, TTLs 1 through 8, because I'm not going to use anything higher than 4. And then I'm going to choose DAC 1, 2, 3, 4, and 5. 5 will be my Z. All right. So I don't know if you can name these here. I don't think you can. Hey, let's try. I've never done this before, actually. Let's try TGSZ. And here we'll call this like TGS Laser 4. They'll probably yell at me because I'm doing this live in a video demonstration, which is a big no-no. But I like to live on the edge. All right. Let's see if this thing blows up. Yeah, that's kind of cool. It didn't. All right, so device name, TGSL1. So this is asking me what should the power output or the voltage output be for channel 1. This is a voltage range question, and this is actually sending a firmware command into the Triggerscope, and it's using a 16-bit addressable output in a voltage range. So if I want 0 to 5 volt control of a laser, then I'll go ahead and choose about 0 to 5 volt value. And you have a number of values here. Maybe you're controlling a galvo motor. Maybe you're controlling a stage which wants a bipolar input, so -5 to +5 or -10, 10. But in our case, we'll do 0, 5. Most lasers are going to like that. All right, we'll do this for 2, 3, and then 4. That's fine. And then for our Z, we're going to choose, maybe we'll do 0 to 10, just for fun. All right, so that's done. That's cool, but there's a couple other things we have to do. The first thing I'm going to do is go to the Utilities menu. And these utilities will work on any device. So we've already got the kind of like the logical object built, but what we need to do now is assign, for instance, Z. I'm going to tell it, hey, I have a digital to analog output, and I want to set it up so that MicroManager sees it as a stage. So we'll add that. Here it's asking me for a low and high voltage, so we're going to put in low voltage 0, low position might be, you know, -250. High voltage will be 10. Now there is a config file that's made when you run this configurator. This is basically an auto config file generator, and so if you mess this up, the simplest way to fix it is to edit it in the config file in my experience. All right, we'll call this the TGS Z DAZ. Why not? All right. Next, we might want to have a, let's see if we can find state device shutter. So what this is going to do is, I don't think we need to assign anything. What this is going to do is it's going to set up the TTL output to act as a shutter. All right, so we've got that. I hit next. All right, default camera is camera. Default shutter is going to be my state device shutter. Default focus will be TGS DAZ. Right now, this is just a DA device. We haven't set up to be connected to the Triggerscope Z yet. We'll do that. Okay, here we'll probably choose positive is towards sample, because normally when positive value increase, your stage is going to raise, whether it's off of a nose piece or whether it's off of a stage mount. And then the, actually this guy can be unknown because that's the MicroManager Z, but our guy here is going to be positive towards sample. All right. Now we'll have the, let's see, state device shutter. We can add a delay if we want. So we might want to put in like a 1 or 2 millisecond delay to allow the light source to react. So we'll go ahead and do that. Normally this is not needed for, especially for lasers. Some LED engines you might need this. Or if you're using a device that's not an LED engine, definitely consider adding a delay. All right, these settings don't need to be adjusted right now. We'll go ahead and update that. And then here what I'm going to do is just choose a new name. Maybe I'll choose MM Live Demo or something. Nice thing about these files, you can make a ton of these. If you send the configuration info to micromanager.org, it helps them to keep up to date with what people are using in terms of drivers and do debugging and stuff like that. All right, with this done, the next thing I'm going to do is I'm just going to try to directly control the Triggerscope. Now, if you got this far, what it means is that the driver is talking to the Triggerscope. Really, as soon as you load up the hub, if the hub runs through properly, then you kind of know that the driver and the firmware are working properly and talking. So that's good. But now I really want to test it, make sure things are working. what I'll do here is I'm going to go to this device property browser. This is a lot of stuff, but we can kind of whittle it down a bit. So first of all, we'll turn off read-only properties because that's not going to help us much right now. Second thing we'll do is we'll turn off camera properties because I don't need to deal with the camera right now. So now I'm kind of going to get rid of some of these, and pretty soon I see this big bank of TTL stuff. Now, the TTL interface in MicroManager is kind of interesting. The right way to do it is to use this state adjustment. So basically, you're entering a bit encoded state. I don't know if I should go through that in detail. Maybe I'll go through it in another video. But suffice to say that state 0 is off, state 1 is channel 1, state 2 is channel 2, and state 4 is channel 3, and state 8 is channel 4. So I'm going to set up, for now I'll leave that alone, but I will set up, let's see here. Where's my Z? Here it is. Okay, so DAZ, so this is the logical Z device. What digital to analog output do I want to connect to that device? All right, so this is where I'm going to choose TGSC. All right, so this setting here, what this does is it says use the effectively emulated digital to analog Z device provided by MicroManager, connect that to the Triggerscope channel 5 DAC, which is TGSC. All right, so I've done that. The next thing I want to do is set the core shutter state device to Triggerscope TTL 1 through 8. Okay, what this is going to do is if Triggerscope 1 through 8 is anything other than 0, and you quote-unquote close the shutter, then it'll drive it to 0. And if it's other than 0 and you open it to shutter, it should drive to that value. So this allows us to treat the TTL output pins as a state control for shutter. All right, so with that done, I will double check my core focus is defaulted to DAZ. It is. And now, if I attempt to drive the stage, I'm just going to have to, I guess you'll have to take my word that it's talking on the trigger scope, but I'm looking at the LED on the trigger scope. In fact, this is a unit that's just come out of test. I'll try to show this. Hopefully you guys can see it. There should be a little LED light that lights up as soon as I start to drive this. All right, and indeed it did. Now if I come back down to 0, let's see, normally it will want to turn off. Let's see. Oh, it jumped a huge number, which is why. So if we come back to 250, it should turn the unit off. Let's see. Well, and it went below the minimum. Oh, that's because I'm using the wrong stage. There we go, and it turned the light off. So here we're outputting greater than 0. Here we're outputting 0. So that is indeed working, and that's great to see. This other Z control here, this is controlling the emulated MicroManager Z stage. We can just get rid of that right now. Cool. So this works, and that's what we want it to do. So the next thing we'll do is we're going to bring our focus over to here, which is the TTL on-off LED. This indicates whether a TTL is active. You can see if I go to the device property browser and I directly enable one of the TTL channels. Let's go down here. Again, we'll just try to put that in the camera field. Let's see here. Okay, so my TTL channel is not on. And why is that? Most likely because my quote-unquote shutter is closed. So if I come over and I open my shutter now the TTL output has turned on. And the reason for that is I've set the output underneath the shutter control. So what this means, if I turn this back off, yeah, so now I use the shutter and it should turn off and on. Now if I set this guy here up to about 100 milliseconds so we can clearly see it, we should be able to auto shutter and see that the current TTL output is going to turn on when we snap an image and then turn off when the snap is finished. And it did. So the shutter control is working properly. So the next question is, how do I assign multiple channels to be controlled via the use of the TTL and analog outputs on lasers 1 through 4? What I'll do is I'll go to a group. This is the group button down here that adds a group to our list here. And this group that I'm going to use, we already have a channel group. Probably I should just edit this guy. Let's see. We'll edit him. I'm going to look at what has been selected. Looks like not much. Okay, the dichroic label, we'll leave that in. Emission label, excitation label, these are already pre-done in the demo. You can imagine if this is a motorized microscope, this is exactly how it would be set up. What I'm going to do here is I'll choose TTL 1 through 8 state, and I'll choose laser 1 power level. So in this case, volts. Laser 2. Now this is the group control. So the idea here is that a group grabs, like anything I check off in this group, it means that, hey, as I'm modifying or if I'm switching between different settings in this group, these are the objects or devices I want to play with. And then the presets assign the specific place I want to put each device for like channel 1, channel 2, channel 3. So, all right, I've got that set. So now if I go to, for instance, the DAPI channel, we'll edit the preset. And what we can see now is that I have TTL 1 through 8 state is now enabled to be saved in this preset. So let's say channel 1 is on and my voltage output might be something like that. And so now I'll save that. And when I go back into it, so we'll go FTSE, go back to DAPI, what I should see here is if I edit the preset, indeed 1 through 8 state is channel 1 and channel 1 has voltage. Now, you don't have to change the voltages on each channel every single time you switch between, say, DAPI to, let's go to Sci5, right? What I mean by that is, let's say I have Sci5 hooked up to line 4 here. Do I need to update laser 1 to be 0? No, I don't. Now, in this case, I'm doing that, but I don't have to do that. This would be on 8 here. We'll go 3, 4, 5, 6, 7, and 8. You don't have to have these settings, these power settings encoded into a preset. There is another way to handle them, and the way to handle them is to actually put them down here in your group. I might show that just to show an alternative method of control here. But in this case now, Sci5 is set up so that TTL line output 4 is active, and my power level for my appropriate DAC is going to be brought up. So if I want to switch my channel, Sci5, I snap my image, go back to DAPI, snap an image, and my settings are going to flip-flop as the system acquires. And that'll work in multi-D, and the shutter will control the output for being on or off overall. So I will show really quick. We'll hit the edit group button, and I'm going to pull out the, let's pull out these voltages. Just show the other way of doing this. All right, so in this case, channel only is going to have control over what TTL outputs are enabled. The idea there being that lasers typically have a voltage level in for attenuation, and then they also have a TTL in for on and off control. So if I want to just keep the laser powers the same through the duration of my experiment, which most people want to do, and only trigger on or off a laser based on the TTL output, then I still want to have control over the lasers, so where do I put them? So here I'm going to put them in the main group area, and I'm just going to choose one laser at a time. So I'll go down, and we'll scroll to, let's say, all right, so here's laser 1. We'll go to voltage. We'll check it on, and I'll call this DAPI power. Now, I did something kind of not super smart here, which is this is alphabetized in the group, and I'm using names instead of like numbers. So now they're all going to be scattered around based on their alphabetization. So maybe we'll edit this and say L1 power. All right, and then as we add these, we'll just call them L2 through 4. So we'll go down. Let's go ahead and get laser 2, laser 2. I'll probably stop here just because I don't want to bore people. This is long enough. All right, so here's laser 1, laser 2. So in this case, I could have laser 1 through 4 power. I can set the power adjust here, and then I'm only going to choose the on-off of those lasers by controlling the TTL state to trigger them on or off, or to control them on or off. So this is kind of a basic way of setting up MicroManager. Again, this kind of assumes a 4-line system. This assumes that each of your lines has a voltage input, and it also has a TTL input for on-off state. Now, most LEDs do, most lasers do, and there's nothing wrong with running it this way. There's also nothing wrong with, say, you have a laser that has a power level control using a proprietary software package. Many lasers will do that, and then you might, want to control on-off states, and they'll offer an on-off TTL input, but the power state will be through USB. That's fine. You can open up the power control, configure it as needed outside of MicroManager, and then just run the TTL control from inside MicroManager using the Triggerscope. In addition, many LEDs and other power sources, even older power sources, can use voltage and analog input for control. So sometimes you only have voltage. There's actually a digital to analog shutter device built into MicroManager. So let's say all I have is analog voltage. Well, when I turn the shutter on, what happens is it sets it to whatever the voltage is that I want, and when it's off, it sets it to 0. So there's a lot of flexibility built into MicroManager. Pretty much, if your device has got a voltage input anywhere from -10 to +10, if you have MicroManager and you have a Triggerscope, we can control it. So I hope this has been helpful, and I hope I didn't bore people too much with a kind of detailed video. Let me know if you have any further questions on how to set up and configure MicroManager with the Triggerscope 4. Thank you.